Alright, Pierre, I'm going to do a little video on the two questions you had around learning test and specifically law number 2 of the 3 laws of TDD. Excuse me. So let's start with the learning test. I've got an example here for FizzBuzz. The kata, I've kind of done my own little thing. Let's go find the katas here, FizzBuzz. So at the end there's a bonus section around returning whiz if it's a prime number, and it says only to worry about numbers up to 100. So I think the question from Clean Code was around discovering an API through a learning test. This the same idea. It doesn't matter how big or small the problem you're going after is. It's really around isolating and creating a space for you to experiment, to kind of understand things. Funny story about that. That's actually how the whole BizVoIP system got started. I wrote 6 learning tests, and 6 months later I built the system. Literally just around the APIs, just trying to figure out how it all worked, and start with the simple things like, can I get authentication to work? In that case, yeah, you're writing a test against a real live thing. Nothing wrong with that, especially in these types of scenarios where they are learning tests. In the scenario I have here, I'm trying to figure out a way to calculate a prime number. It's not something I do every day, so I'm going to find it challenging. And in the context of the kata, it is challenging. So what I did is kind of do what I always do with a test. Is I always start off by saying it's a learning test underscore goal, and then what the goal is, calculate primes. And I find this helps frame your approach, like any other test where you give it a good name. It helps frame your understanding of what you're trying to do. Now, what I have here is something I ended up at. Likely with a learning test, you're going to iterate and cycle through while you're trying to get it to a place where it makes sense. You may want to create multiple learning tests. You may want to work with one learning test and kind of just evolve it. That's really going to depend on your level of comfort, how big the problem is. Bigger problems, you might want a few tests. Like I said, I had 6 for the BizVoIP system. Problem like this, calculate primes, I'd probably be fine with one test. It's a pretty succinct problem. It's not going to be too difficult to figure out what's going on, and if I want to keep my code, I can always comment it out before I change it. So the idea here was to isolate this concept, be able to operate on it simply. Maybe if I didn't start with something at this level, I could have just said is prime true, because that's what I'm expecting. Seems kind of silly. Maybe I would have written another method called check prime, and it'll take a candidate number, and let's say I generate this method. And then we can come back to this idea of TDing out the understanding, where maybe I do a fake it, return true. Seems a little more sensible here than just setting a boolean. But then maybe I want to give it more intelligence. So like if candidate number equal to, return true, return false. Run my test, see what happens. Let's actually run my test and see what happens. Let's do the TDD thing. I don't know why my Visual Studio's gone back to being a weird theme, but I'm probably missing a whole bunch of things. So this is an old bit of code from about 3 years ago. I'm pretty sure I'm missing some libraries or packages or something, so my apologies for not being able to actually run the test and show you. But the thinking would be, starting off with a learning test, I can create another method. There's nothing that says I have to do everything in the learning test. I'm exploring an understanding. And maybe I'll evolve an abstraction in doing that. Or maybe I'll just evolve a method. Who knows? So the idea being that I'm going to take small steps. I took a first step of just returning true, because that's what I was expecting. Maybe I'd change this to being something that's not prime, like 4. And then I would get a false. And then, obviously refactor to candidate number 2, and then I'd be like, oh, well, I know 3's prime, so run that, candidate number equal 3, and, work through that fake it until I go, there's got to be a way of doing this. And Well, that's how I came upon the enumerable stuff. Eventually, through some Googling, after looking around to see if there was a better way, that's what came up. Because I had my learning test, it's really easy to do. In the context of the FizzBuzz cart, it's even possible that I would have put the method on here and realized it was too big of a problem. That's kind of what the whole idea in reverse gear is. Let's actually jump to the gears quickly. So, if you get stuck, you're struggling to refactor, find the next test, the concept feels just like a big jump, you're not comfortable, you're not sure the steps to get there, then breaking out into a learning test is a really good idea. It helps you really kind of cement your understanding of that bit of the problem that you're trying to solve without focusing on everything under the sun. Even a unit test can feel a little bit big, especially when something's so foreign. So that's the idea of a learning test. It's really just a space to understand and explore a concept. Let's go to the 3 laws question next. Just keep scrolling around. I should have this all put together. So you're not allowed to write any production code unless it's make a failing unit test pass. So don't write any production code unless you're trying to make a test pass. You can refactor code, but that's after it's gone green. You're not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are failures. I believe this is the point you've got some questions around. So there's 2 parts to this. The first bit being because when you first start out TDDing things, if we go back to the FizzBuzz example, when I first started this, I would have said something like, hold on, my computer is suddenly having some concerns about what it's doing. I would have said something like this. And this wouldn't have existed. In fact, let's go make it not exist. And it's going to be like, hey man, that doesn't exist. That's a compilation failure. I now need to actually stop typing code in my test and resolve that compilation failure. In this case, uncomment out the code, but in real life, create the class. So that's the first part. That's the one. Actually, I think that's the second part of the question. And compilation failures are failures. So that's the idea there. Is as you're typing things out and bringing them into existence, you need to stop and actually create them. Or another way to think about this is while you're refactoring, usually big refactors, not after a test, but maybe you've got to go deal with some legacy code more specifically. You could use the compilation failures to kind of drive towards the ultimate single passing test compilation. But that's kind of a more abstract, tangent way. The more traditional way is bringing things into existence and stopping to fix them as they go. You're not allowed to write any more of a unit test than is sufficient to fail. So the idea here, let's go back to my FizzBuzz example. If we really take this back to its core concept and kind of think low gear, for this test to work, and this is my first test, I'm going to say, take all the test cases off. All right. All right. So back to my first test. 1 equals 1. Now if I run it, it's going to expect me to do something. I can return 1. If I returned in low gear, so remember, there's kind of gears here. There's different ways to think about the scope of what you're allowed to do. In low gear type of problem, triangulation, fake it, this would be too much code. Simply because I've solved too much of the problem. Now, any test I write after that, where the input's going to be the number, will all pass. But we're in low gear. That's why we're thinking that way. So I would return 1, and then I would return, what's the next test? 2, 2, 4, 4. So now I've done the triangulation. I'd come back, I'd refactor my code to be this, because I've proven the concept. But that's if we're thinking in low gear. If you're thinking more medium gear, maybe even in some cases higher gear, you could jump right to this, because you know that's what the solution is. It's pretty obvious. That's the whole idea of the obvious pattern. If it's obvious, it's obvious. As you move through the test, obviously you'd work through 3 and 5 and 3 divisible 3 and 5. And the idea being, if you're still in low gear, you're going to take those deliberate, intentional steps of saying, if it's 3, do this. If it's 6, do this. That kind of thinking. Eventually coming to this medium, higher gear, you can kind of jump here quickly, and that's where it's probably most confusing. It's because if you're kind of thinking at a little bit larger level, how much code is too much code, and it's really, is that concept covered fully? You haven't introduced a secondary concept. So FizzBuzz probably isn't a very good example. Age calculator might be. Oh, I don't have anything in here. I have a to-do list. Yay, go me. Copier. So the copier carta, let's just go have a quick squiz at that. It was about moving copiers. This is about our first carta with n substitute, that type of thinking. So moving from a source to a destination. So from this standpoint, if I went and made it work for more than a single character, I jumped to this solution right away. I would say in this scenario, that's too much code. So it should have basically the addition of the while loop would have been too much, and the reason being is just kind of a one-to-many concept here. There's a way to kind of map this back to a pattern other than the obvious pattern. The obvious is dangerous, and that's the idea of one-to-many. So to get it working for a single instance, and then get it working for many, and that's really what this is expressing for us. So if I jump to the many right away, I would have short-circuited the pattern and kind of lost the value of the thinking. And just it's a small problem, but it's just the clarity that comes with taking deliberate steps. So really, the point I guess I'm trying to make is it's one of these things I think you learn over time through mistake. I can't give you a real concise, this is exactly what it looks like. I can give you some examples for you to kind of reflect upon. And then you kind of need to make mistakes, I think, with it, where things are maybe too big or too small, or you find yourself in a few ruts. But at the end of the day, your learning test is always your best friend. That's really what Law 2 for me is about. Is if I do get stuck, or I've made too much of implementation and it's hard to move forward, and you'll start to feel it. There'll still be a tension as you move. Things just get to be difficult, or too many tests fail for too many reasons. So maybe that's it. If the code feels hard, or the tests feel a little smelly, or they feel a little big, then you're probably writing too much code. I can't give you like if you're writing more than 2 lines type of thing, but it's something I think it's an intuition you learn over time. Absolutely is. But if things are getting hard to work with for whatever reason, then it's likely that the tests are too large, and that you maybe written too much code for what's happening. Or it may mean that you're just dealing with a really large integration, like we do everywhere in the system, and sometimes you just need a lot of moving parts to make that happen. So I hope that's clarified things a little bit. Maybe you've got more questions, which would be great. We can talk those through too. Otherwise, I think that's everything I got to say, except go team!